Hey everybody, this is Mr. Munson, and we are still in Unit 9. We're kind of coming towards the second half of the game. We're in unit or concept number 3, deductive reasoning, compound statements, and Venn diagrams. So take a look at the following series of statements down below. They're just a series of if-then statements, and so I'm going to give you a series like this, and ask you questions similar to what I'm getting ready to tell you. Okay, so let's just read through them real quick. If a shape is a square, then it's also a rectangle. I think we all agree that that's true. If a shape is a rectangle, then it's also a parallelogram. Once again, that's true. If a shape is a parallelogram, then it's a quadrilateral. I think we all agree with that as well. Okay, so the question is, what conclusion can I make if I was to know that something is a square? And so at some point at the end of this lesson, you would say that the shape is also a quadrilateral. The first thing happened, then the last thing happened. There's a pattern that's going on in this series of conditional statements that you'll be able to notice and make sure you know how to process. All right, let's get started. Okay, so we're going to cover 3 topics as we go through this video. And one is what deductive reasoning is, Venn diagrams, and also compound statements. Okay, so I'm going to ask that you put me on pause, find your student learning map, and look at your words that are the vocabulary words for this section. Review them before you go any further so that as I'm talking about them, they're fresh in your mind. I'll wait here until you come back. All right, so the law of syllogism is a law. It's a property, if you will, that we're allowed to use on a series of conditional statements. Okay, so if we have a list of conditional statements such that the conclusion of this one ends up being the hypothesis of that one, and the conclusion of this one turns out to be the hypothesis of that one, they kind of fall in a chain like that, then we can write a conclusion. So if you look down here, I have a little stack of 3 balls, like cannonballs stacked up. That means basically in symbolic form, conclusion, or the word therefore. So if I have this P then Q and Q then K and then K then L, what conclusion can I make? Now, using the law of syllogism, I have a specific answer here. That answer is this. If P happens, then I can assume L will happen. Okay? And it's just a series, like a chain of events. Okay, take a look at this. These 2 conditional statements. Analyze it according to what we just talked about, the law of syllogism, and then see if you can write a conclusion. Now, I'm not looking for it in symbolic form. I'm looking for a conclusion written in the verbal form. Okay, go ahead and put me on pause. See if you can do this on your own. Okay, if you work hard at the gym, then your clothes get wet. So all I did is I recognized that the first part of this statement, the second part of that statement, then you sweat. I noticed that that was in tie with the first part of the second sentence, so they match up. Since they do, then I can take the first part, the hypothesis of the very first sentence, conditional statement, and match it up to the very last one of the next sentence, right? So then your clothes get wet. Okay, so if you work hard at the gym, then your clothes get wet. That's the law of syllogism, and I'm using that law to come to a conclusion here. Now, I haven't said if anything, what has happened, did my clothes get wet or anything like that. I'm just simply recognizing that there's this chain of events, that the first thing happens and the very last thing happens. All right, to help you kind of process and make sure that you can do this on a test or quiz, I've written an original conditional statement, P then Q. Okay, and then I wrote some other variations of that, and what I want you to do is on the left or the right hand side of each one of those, I want you to write down which one's the inverse, which one's the converse, which one's the contrapositive. All right, put me on pause and see if you can do that on your own. All right, just for the sake of room, I've kind of abbreviated these. Wasn't it convenient? I told you the answers as we were walking into it, right? So the inverse, the converse, and contrapositive are given there. Now, I also told you in a previous video that if I know this conditional statement is true, if it's raining outside, then the parking lot is wet, then I also know that its contrapositive is true. If the parking lot is not wet, then it's not raining outside. Okay? And the reason I said that is because it is true. And whenever the original statement is true, the inverse or the contrapositive is true. Now, to know if the inverse is true or the converse is true, we're not sure. You have to kind of look at those and analyze them on a case-by-case basis. All right, I want you to keep this in mind, that these two statements are interchangeable. So if you see a statement P then Q and you want to exchange it with the contrapositive, you may in order to keep it going. Now, there's a reason I'm bringing this up. Now I have this series of conditional statements, P then Q, Q then K, L then not K. Now this last one kind of breaks up the pattern that was kind of flowing there, and that causes a problem. If there was some way that I could get it so it was a positive K in that first spot, then I would be able to do that. And I can't just move things around. However, using what we just talked about in the contrapositive, I can replace that with its contrapositive. Let's see if that would help out. So now down below, I have the original statement, the L then, L then not K, the last statement there, and I switched the positions of the pieces, then I negated both sides. Now, of course, we're not going to keep this as a not not, so this ends up being K, then not L, okay? So what I'm saying is this, I can now take this K, then not L, I can take this K, then not L, and go up and actually put it in that place, and that will allow these pieces to match up. Okay, now I had to do some work to get there. I can't just do that for free. All right, so now I've got it matched up, and now I want you to know I can do that anywhere in a series of conditional statements if I need to. I can find its contrapositive, throw it in place. So it didn't have to be the last piece. It could even be the first piece I'm having to switch around to make work. Okay? All right, so from this conclusion, I know that if the first thing happens, then the last thing happens. That's the law of syllogism. All right, let's move on. Okay, let's take a look at the law of detachment. So the law of detachment says, suppose I have a conditional statement, P then Q, and I tell you, hey, P happened. Then you get to conclude that Q happened. So what I want you to do is I want you to write a conditional statement you know is true, okay? And then I want you to say that the first thing happens. So you're going to write a sentence, an if-then statement that's absolutely true, something about your life, whatever. Then I'm going to have you say, hey, blah, 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 happened, right underneath it. Then I want you to draw the little cannonball things and write what the conclusion is. And it should match exactly what the conclusion is in your original conditional statement. Now, if all those words just pass by you and you have no idea, don't just allow this thing to go ahead and for you to see what I do. I want you to go back and listen to those words and see if you can think it through. That's the whole point. It's the processing that you're learning how to do. The fact that you can't do it is telling you have to go back and do it. Okay? Put me on pause, write your sentences, and come back. All right, over on the left is or right is my example. If I eat shrimp, then I break out in hives. Oops, I just ate a shrimp. All right, my conclusion is very straightforward. Yikes, I'm going to break out in hives. All right, let's move on. All right, so here I have a series of conditional statements and K happened, okay? So what I'm going to do is I'm going to use this here in the law of syllogism, right? Law of syllogism, and then the fact that something happened, I'm going to use the law of detachment to come up with a conclusion. Okay, so go ahead and see if you can put me on pause and work through this one. Kind of reflect back on the two examples that we just did, one with the law of syllogism, one with the law of detachment. The first thing I'm going to do is I'm going to take this one out and put that one in its place to make sure that things line up properly. That's the contrapositive of that one. Okay? All right, so it lines up correctly. The last equals the first all the way through this series of events. Whoops, part of my problem here got erased. Should be a T there. Okay, cool. So through the law of syllogism says if the first thing happens, then the last thing happens, as long as everything is lined up correctly. So I can basically use the law of syllogism, let's get rid of that, to say if K, then T. But take a look, K happened. So using the law of detachment, I can now say T happened. All right. Now, for many students, they'll be confused at this point because they've gotten two different laws and they're getting them mixed up and they're not sure what happens. So if you're confused right now, your job would be to go back in the video and rewatch those pieces that caused you confusion. If you're at this point and you're confused, it's probably because you went on past a point you were confused to begin with. Okay, let's go ahead and move on. If you're going to go back, put me on pause. Otherwise, let's go on. Okay, let's take a real quick look at Venn diagrams and also compound statements. So as you can take a look, these two Venn diagram, or this Venn diagram has two circles, one for rhombus, one for rectangle, and where they intersect is squares, right? And so if I was to ask you how many of the shapes that are in, the dots represent shapes, right? How many shapes are rhombuses, right? You should be able to count the green dots for how many are rhombuses, okay? So you take a look and you count, I get 6. Now take a look and see how I got 6 for rhombus. The reason I have 6 is there are 6 dots in the rhombus circle, okay? 6 dots. Now nobody said that they couldn't be squares, it's just how many rhombus. All right, so what I'd like you to do, let's figure out how many rectangles there are and how many squares. Put me on pause and come back and check your answer. All right, I've got 5 rectangles and 2 squares. Hopefully you got that right. Now if you look at this shape, this means and so I'm looking for which shapes are rhombuses and rectangles. How many of those things? So for that to be true, for this statement to be true, for you to count the item, it not only has to be a rhombus, it also has to be a rectangle. That's what the and requires. It requires a truth on one side and a truth on the other. Okay, see if you can figure out how many shapes are rhombuses and rectangles at the same time. Okay, so if you look at this shape right here, this one's a rhombus. That would be true on the left, but it would be false on the rectangle side. Okay? So the only ones that satisfy this category are going to be the ones in the middle here that are squares. Now for a rhombus, or for the or statement, this would require either a truth on one side or a truth on the other, but it doesn't require them to be truth at the same time. For something to be counted here, it could be a rhombus, or it could just be a rectangle, or certainly it could be both. Okay, so let's just take a look and see if we can categorize this real quick. If I grab this dot right here, I know that that's a rhombus or a rectangle. It's a rhombus, so it puts a truth on the left-hand side, so I know that counts as one. And so that certainly that one does, and so on, okay, all the ones over here. Now, how about the one right here? If we look at this one, it's a rectangle, and so to be counted, it's either a rhombus or a rectangle, so that one counts, and so on, right? Now, how about this one that's in the very middle, not the one that's waving around with it in the rhombus area? Well, that's a rhombus, and it's a rectangle, and that's totally true. This would be a truth rhombus and a truth rectangle, so that would still count. So, from my calculation, there are 9 shapes that are either a rhombus or a rectangle. All right, take a look at this problem. Left and right-hand side to disperse the information. We have a total of 6 people that we're talking about. And count the people down below. You got 6 people there. And we need to put them into their categories, okay? So the total number of people who like to swim is 6 or 3. The total number of people who like to jog is 4. And the total number of people who like to swim and jog is 1. Now, if you total that up, it comes up to 8. I don't have that many people. What you have to realize is that with this jogging people, there could be some of those that like to swim as well. And so what you want to do is take these people and throw them up into the categories until you can get this to work, okay? That you can see that there are 4 people in the circle for jogging, okay? All right, put me on pause, come back and check your work. Now, I always throw this person in there first. He's the one that has to fit there. He's going to swim and jog. And if you take a look at the circle to the right, there's 4 people that are in that circle. That's 4 people that like to jog. If you look over here in the circle for swimming, there's 3 people who like to swim. And, of course, you have the one that likes to do both. All right, that's it. Let's go to our do it problems. Okay, there you go. There's your do it problems. Hopefully you did your summary. And I'll just scroll this along so that you can see it in a bigger format. You just put it on pause when you need to. And there you have it. Hey, if you like, two things, check in the comment section just below the video, and I might put a link to this page right here so you don't have to copy it all down. You can just print it up and write in your information. Make sure that when you come into class next time, I could give you problems that are very similar to this and you could do them. That's how I'm going to check your homework, okay? In addition, make sure that you understand your vocabulary words for 9.3, that you'd be able to recognize what those vocabulary words are and what they mean if I was to pop a quiz on you. All right, that's it. Take care. Hope to see you soon.